Hi there, folks, and welcome to another episode of Michael's Backyard Marina. You might ask yourself, what's going on behind me here? Why is your trolling motor in a test container used for outboards? Because I'm crazy. What you currently hear going on behind me now, I bought 2 FVP batteries from Menards, which is a local big box hardware store here in Iowa. They were on sale, $104 a piece. I bought 2 of them, Deep Cycle marine batteries. So I thought, sure, why not? My other 2 batteries were dead. They were 3 years old, no good anymore. Bought those. Then I got to looking online, and I actually looked online before I bought them. This place called Dakota Battery, the link will be below in the bottom, or maybe I'll just put it right down here. And I'm not sponsored by these guys, but I thought they had an interesting product, some newish technology, fresh technology, I don't know what you want to call it. It's not that new, but it's newer than lead acid. And but they're expensive. Sticker shock, wow. 2 12-volt, 56 amp hour batteries is $989. But I thought, they have a lot of awesome features, like 11-year warranty, over 2,000 cycles. That means you can recharge it up to 2,000 times or more. Your normal lead acid batteries, 300 to 500 times. They're toast, they're done. Which 300 to 500 is a lot unless you go fishing every weekend, or 40 to 50 times a year. You're charging them batteries up every time because you're using your trolling motor every time. So I bought these 2. They're FVP, Frank Victor Paul, FVP batteries, and they weigh 59 pounds a piece, and that'll be pertinent later in the video because the Dakota batteries, well, it's pertinent now. The Dakota batteries claim 31. That's a lot of weight savings when you're talking 2 batteries. I got 118 pounds of batteries in the front of this boat. And if I can take that down to 62, that's not a bad deal at all. And get more performance and more everything. So what this is I'm performing a test with the old Minn Kota Ulterra. Nice thing about the Minn Kota Ulterra and a lot of the newer trolling motors, they will not let you take your battery down lower than it should be. For a deep cycle battery, it helps protect your battery. That's what it's there for. And then you can recharge it, bring it back up. Well, I thought, let's see how long these FVP batteries would run. I've got a timer currently going, and I've got it in water. I've got this set at 5, my foot controller set at 5. And I set it for every 30 minutes is what I'm gonna do. Every 30 minutes, I'm gonna check and see how things are doing. We're at 21 minutes and 42 seconds left on the first go round. And the reason I got it in the water, I want the resistance of water. I want it to mimic kind of being out on the water, but I want a more controlled environment, because when you're out on the water and I'm going to compare 2 batteries or 2 brand names against each other, or 2 style of batteries against each other, I want it to be an apples to apples as much as possible. Well, you can't get much more apple to apples than in a barrel of water. Out on the lake, you could have wind resistance. When you're holding it at 5 and in your trolling and you want to maintain a specific speed, well, if you're going against the wind, this thing automatically speeds up to hold your trolling speed, or slows down depending on whether you got a tailwind. So I thought this was the best way to give it a fair test between 2 different types of batteries. And being these are not the most expensive batteries on the market by any means when it comes to trolling, I'm probably one of the cheapest. Let's just see how they hold up, because if I'm out in the lake, I like to be out there trolling sometimes 5, 6, 7, 8 hours of just trolling. And I do have a kicker motor on the back of my boat that when I'm out on big lakes, I'll just kick that in. But sometimes you just like the peace and quiet of an electric trolling motor while you're out there on the lake enjoying some lake time and some fishing time. So she's turning away pretty good. We've got a digital voltmeter on the dash. I will flip that on. We'll see how the voltage is looking every half hour. We started out at 12.2 volts. That's batteries charged and then sitting for a day or so, and then we're putting it to use. I just checked it. It was running 11.9. So we'll see how this holds up. These batteries may not be the cat's meow. They may be I'm glad I'm doing this because I could be out in the water and an hour and a half later the batteries are discharged enough I can't even use my trolling motor. That's no good. I need a trolling motor battery that will hold up to me in my use for all day. Because a lot of times I go out to the lake, I'll get out there first thing in the morning, sometimes I'll spend all day. There's some lakes that are really cool you go to that you go out there and fish all morning. They got some lunch by the lake that you can pull your boat up, dock, and go eat some lunch, take a break, get out of the sun. Then you feel recharged, you go back there for the rest of the afternoon. Especially when you drive 2 hours away. I spend as much time out there as I can on the water. Not all my lakes are 2 hours away, but my biggest ones are. So we're gonna let this continue to run and we'll report back to you on how it's doing. What I'll do is every 30 minutes, we'll see what I wanna do. I might stow this thing, but I'm gonna see if it responds. We'll be doing the left and rights here and checking some voltages on the remote, what it says, compared to what the dash says as well. So let's let this thing eat for another 20 minutes and we'll be back to check it. All right, we're already over 30 minutes in. We're about 10 minutes into the next 30-minute segment. Trolling motor is still going strong. I'm gonna show you the volt meter, and I'm gonna show you the remote control as well to show you what it's saying right now at this point in time. Currently, the boat is showing 11.8 volts. It's been at 11.9 to 11.8 volts from the first 10 minutes. It's holding steady. I've seen it pop up over to 12 a little bit, but the batteries are discharging at a pretty regular rate, pretty even it looks like, so I'm pretty happy with that. This switch you see on here is to turn this on and off. So I have the ability to turn these power outlets on and off. Now I know it may be difficult to see in this light, but on the remote, there's a battery light right here, or there's battery indicators right here telling you how good the battery is doing. The little 4 bars there will give you that information, along with the little battery signal on the left that tells you how the remote control is doing. I actually just recharged the remote control with the power in the boat, drawing off those batteries, because that's a real life situation as well. So far that's doing pretty good. We're at 4.5 on the prop speed. I can bump this up to 5, 4.5. We're running at 4.5 for this test. But yeah, this is, everything still works. I can stop. I can left and right still. And if I go down here to Ultera, I can go up. I can go back down. And I can turn it back on. All right, we'll check in another half an hour, or about 20 minutes. All right, that sound means another 30 minutes has gone by. The voltage is holding at 11.9. The motor's running, the trolling motor's still at 4.5. We're an hour in, it's going strong. I have no issues at this point in time. Let's check in another half hour and see how things are looking. I may skip a half hour now and then just because, let's just call it no change, so why waste your time? So, going good so far. All right, folks, the timer just went off. We've completed 6.5 hours. This thing's been running constantly for 6.5 hours at 4.5 or 4.5 on prop speed. The digital dash says it's down to 10.8 volts. I'm waiting for my trolling motor to tell me that's enough. She's still going strong. 6.5 hours. It's getting right in there in the sweet spot, I think. We'll check back in it in another hour, half hour, hour and a half. We'll see how she's doing. All right, folks, we finished with the first test. We ended up with 7.5 hours of runtime on those batteries. That's not too bad. That would tell me that's probably around, I don't know, 50 amp hour, 60 amp hour, somewhere in that range maybe. You guys decide. So from a full charge to 10.5 volts. Deep cycle batteries, lead acid batteries should not be pulled down below 10.5 volts. That's when the trolling motor will actually shut itself off, which is exactly what it should do. If you got an older trolling motor, it doesn't do that. you should have a voltmeter or some kind of little digital display to tell you what your battery is, how they're holding up. But yeah, they were down to 10.8 at the 7-hour mark, and somewhere between the 7 and the 7:30 mark, 7.5 hour mark, that shut off. So I'm calling it 7.5. So those FVP batteries, you know, if I was out there trolling all day, it would have done the job. I've got the charger on it right now, charging them. We're going to bring them back up. We're going to do this one more time, just to do the average between the two, and then we'll do a comparison on the Dakota battery when I receive it. Some of you might ask, why are you doing this? Why you just used up a cycle? You only have 200 to 300 of them. Absolutely correct. But I'm doing it for you guys. I'm doing it for myself. I'm learning. You guys can know what to expect out of maybe an Ultera 24 volt or any kind of Minn Kota 24 volt and 2 FVP batteries. And then you hopefully know what it'll do with two Dakota Lithium Lipo batteries. Why are the bugs out here bugging me? Guess they're doing their job. Bugs bug people. But so we got the charger on it, charging them up. We'll back out here. We'll drop it back in the water tank, and we'll do it one more time. Yep, charger's just blinking away. This charger I've got in here is a little. It's made by Battery Saver. It's a 50 watt 24 volt. So it's gonna put the juice back in. Usually they'll be charged up overnight. I put this back on charge about 6 o'clock. I'll check it in the morning and I'll let you know how it did. Usually by 6 o'clock tomorrow morning, she'll be back up to full charge. And we'll go from there. Stay tuned, more to come. Well, if you made it this far in the video, I'm proud of you. Glad to know you. There again, I remind you to like and subscribe. What I have in front of me here came today in the mail. It came with a sticker that said, Dakota Lithium Boondock. 11-year warranty, 30-day money-back guaranteed, blah, 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 lifetime technical support, 11-year manufacturer defect on all batteries, 1-year warranty on chargers, power box, case, and accessories. Yep, you guessed it, I got my Dakota batteries. They're still taped shut. I wanted to open it up, and I'm not big on unboxing all the time, but this is kind of a special day for me. And I say that, it's a special day for me. It's a special day for you too, because you're learning about stuff. Now these batteries, here's the invoice. I ordered the Dakota. This is the SKU number, DL24V54AH. So that's a 24 volt, 54 amp hour battery kit, basically. Dakota Lithium 24 volt, 54 amp hour deep cycle marine trolling battery kit. $949. I'll leave a link to everything down below. I am not sponsored by these guys. I just purchased their product. We're going to give it a review, and I can give you an honest review like I always do. I never lead you guys down a primrose path and sell you junk. Nope. Let's open this up. First thing you notice, pretty darn light. Now we already said that the lead acid batteries were 54 pounds or 59 pounds a piece, not 54, 59. This taped in there, a little package that says screw. Let's see what we got here. Let go. I'm just going to dissect the box a little bit. Very well packaged, lots of foam around it. Box inside a box. It's a double unboxing. Let's open this up. Now one thing it does say on the side here, other side, go further, last longer, play harder. It says to optimize your battery performance, charge prior to storage, Charge your battery prior to initial use. We recommend your battery be charged using the lithium compatible charger. Avoid charging your battery below 32 degrees Fahrenheit. Operating temperature range is minus 20 to 120. It's a 100 degree range. So operating temperature minus 20, that's important. So a lot of these other batteries don't hold up to the cold. And not over 120 degrees. By golly, if it's 120 degrees where I keep these on my boat, I'm in the wrong place at the wrong time. Now it can get that hot. I hear a lot of stories about Lake Mead and what's going on out there, and the guys that are doing the reviews on that and how hot it is out there. Don't throw the little bag of screws away. Getting smaller. All right, let's see what we got in here. It gets smaller. There's more packing. Woo-wee. Now this battery is so light, you can lift it out just like that. Now try to do that with 59 pounds. I'm not a bodybuilder. I just play one on TV. Oh, it's got a go handle. Boom. They claim these things weigh 31 pounds. I don't think so. Boom. You know, that's a good looking battery. What do we got here? It's got a threaded hole here. And a threaded hole here. These are very nicely made, very nice looking batteries. I'm gonna weigh one. Let's see what she weighs. Now I think we all would agree that that scale reads 0. This is the exact same scale that I used to measure the other batteries. Which came in at 59 pounds. 59, that's over here. These are in 10-pound increments. This sucker is sitting right on, that's 20 pounds. 118 pounds is what the lead acid weighed. 118. I'm going to do the math right in front of you so you believe it like I do. Minus 40, 78 pounds lighter. That's a whole medium-sized human being. 20 pounds. Stunning. That's remarkable. 40 pounds between two batteries that have 54 amp hours, 12 volt. So the cool part is, like I said, this works out great because I can wire up my boat the same way. Now, for the same money, what do we got here? A 12 volt, 10 amp charging. It came with the charger for that same price. What's in this box? A second charger. This is a 24 volt 5 amp charger. And this is a 12 volt 10 amp charger. The cool part about the 24 volt is I can hook this right up to my current system. That's awesome. and charge it 5 amps at a time. I don't know, 5 amp hours, 24 volts, blah, blah, blah. 2 battery chargers, 2. So I can play with these independently and charge them. Now let's look at see what kind of screws came with it here. This is the screws. Because these have threaded holes. Two different length screws. So short screws if you're just hooking down one wire, longer screws if you're hooking down a stack of stuff, or you can hook a terminal plate on here. 2 heavy washers with it too. Now you wonder if these are standard or metric threads. They're metric. And I think what I'm going to do is something a little different. I'm going to buy me some screws, some nice screws, whatever I can find, make a stud out of it basically. Double nut it. I'll show you how I do that, and then screw it down in here to kind of tighten it up and kind of hold it in place. And then I'll get me some metric wing nuts, and I'll wing ding ding zing them down on there, so I got wing nuts just like I have now. I'm gonna read a little knowledge here. Let's see. Ensure the charger cable is plugged in securely into the charger. Plug charger directly into a functional wall outlet, because a non-functioning wall outlet will not charge your batteries. Yep. Do not plug charger into power strips, extension cords, or surge protectors, as they may interfere with the charger's ability to deliver a full charge cycle. Noted. LED will be green. This indicates that the charger has power. If the LED is red, flashing LED, flickering LED, or no LED can discontinue use. Contact Dakota Lithium support. Clip charger leads to the battery terminals using the rubber hoods, red to red, black to black. This all seems pretty right? Avoid charger leads making contact with each other, as this can cause a short. LED will turn red on the charger, indicating that the charger is delivering the power to the battery. Note, if the LED does not turn red once clipped to the battery, use a DC voltmeter to check the output voltage of the charger and the battery. If the voltage is reading below the charger and the battery specifications, contact Dakota Lithium support. The LED will turn green when the battery is fully charged. You can now disconnect the battery from the charger. Do not leave charger on fully charged battery for longer than 16 to 24 hours. Unplug charger from wall and store in a safe area. So this sounds very important, because I'm in the habit of my battery charger that I have in the boat now is currently a charger / battery maintainer. I leave it plugged in for long periods of time. This is something I'm going to have to change some habits on, or maybe I'll do some research, or you guys can tell me what you do with your lithium batteries. That seemed like I was prolonging things. I was not. We're going to throw some voltage on, a voltmeter on here. We'll bring out the old digital volt 20. That should cover it. Let's just see what these each have. What happened? My battery's dead. Are you kidding me? Is that ironic or what? How can my battery be dead? I only use it all the time, every 10 years. Well, I'll be dipped. Dead battery. Well, do I have another 9 volt? All right. 1301 volts on this battery. 12.97 on that battery. That's what it's got right out of the gate. we're going to go ahead and put the old charger on it. It says it has lights. Curious to see what lights up here. Ooh, a little fan running in there. I'm going to set it down. Well, heck. There we go. That's got a little fan running and everything for the 12 volt. So red means it's charging. Green means it's charged. So it's about 11 o'clock at night. We're going to let this charge overnight. And like it said, don't leave it charged and plugged in for more than, what was it? 16 to 24 hours. So overnight, we'll let her rip. That way I know it's got a full charge on it. And we'll see it in the morning. Alrighty, we're checking in on our batteries. A short 10 hours later. This one we had on the charger. The light is now green. I'm going to switch it over to the second battery. Little fan kicks off again. We're going to see what kind of voltage this one's at now. 13.33. 13.32. All right. The other thing that they thought of at Dakota is they sent me 2 little tubes of dielectric grease. Every good mechanic shop has dielectric grease on hand, but it's always nice to get some with your purchase. That's pretty cool. That little fan on that little charger got a little noise to her. I'm going to take one of these with me today and see if I can discover what size thread they are, and I'll fill you in on that information and show you how I'm going to use these, how I'm going to create the stud and connect my wiring to these batteries. These batteries are much smaller physically as well than my lead acid. When I say much, a few inches each way. These are going to fit right in the battery box where my other batteries went with ease. Alrighty, we'll check back in this afternoon, be about 10 hours from now, and see how this battery is doing. Alright folks, it's later in the afternoon. Green light was on, batteries are charged. Let's just see what the voltage we got here on this here battery. 13.31, 13.56. This one went up all by itself. Magic lithium charges on its own. I don't know. Anyway, all charged. Next step, I'm going to do a little special stud work here. I'll show you that, what I'm doing there. And then we'll go in the boat for the testing. Okay, guys and gals, I'm going to show you a little modification I'm doing to these batteries. This is personal preference only. I'm going to state that up front right now. But if you notice anything difference between these two batteries, let me zoom in, see if you can pick up on what I got going on there. Now do you see it? Oh, I bet you do now. These came with a socket head. These are 6mm. Came with a socket head cap screw for making attachments that look something like this. Well, there's a long one that came with it and a super short one. The short one's good for putting about one banjo fitting on it, or what do you call it? Eyelet. So what I did, I'm going to show you step by little step, because I took advantage of this and we turned it into that. Now I'm getting in here good and tight so you can see the condition of my hacksaw blade. Oop, there's a hole in it. That's dull. This is dull. The sharp back here, so I'm using this up. But yeah, I could use a new hacksaw blade, I'm guessing. think there's tooth number 4 and 8 down here doing all the cutting. How many of you folks out there have heard the term double nut? I would highly encourage you, do not Google that terminology. But we're double nutting this. And yes, I bought some 6mm nuts. You can double nut this, tighten one against the other. And then you can use that to install your stud that you just created by cutting the head of that bolt off. And I sanded it, made sure the nut passes over this cutoff area. Now I'm coating this in dielectric grease. Then we're going to screw it down in here. And this is where you got to be careful. Now I'm just tightening that down till it stops and just giving it a little tweak, just enough to make that stud kind of hopefully stay in that half of the battery. And then you take back off one nut and the other, you can take it right off. And you got yourself a stud, and you got dielectric grease all around that, sealing things up down in there so corrosion won't happen down in there. And you got yourself a nice little stud there. Now the cool part about this is now you start looking at this distance here. When that nut is fully engaged, I can stack 3, 4, 5 of those eyelet fittings on here and tighten them down. Now I'm going to find me some metric wing nuts because I like using wing nuts. But yeah, so now you can turn a no stud into a stud. Now I'm going to share with you some of the reasoning behind why I put a stud on there. I covered a little bit of it. I can stack up a bunch of eyelets on here, tighten this down. Easier to do that two-handed and try to put all the eyelets on a bolt and start it in here. These batteries are warranted for 11 years. I want you to think about that for a minute. 11 years. So if you take these out of your boat and put them in and out of your boat for 11 years, that's 11 times that you got to put that bolt in and out and tighten it down and run the risk of doing something wrong and stripping out your thread. Now most of you don't have that problem. I don't have that problem. But now the worst case scenario here, I tighten this down with a wing nut. I mean, you could ruin stuff, but I just like the wing nuts, okay? That's all there is to it. And right now I just got a lock washer and a nut on here to hold me for the time being until I find my 6mm wing nut. Well, we're real close. I'm running another test tomorrow on the lead acid batteries. Now I did weigh, just for fun, I did weigh one of my old Napa Premium Marine RV Deep Cycle batteries. I had a pair of them in my boat. They weighed 58 pounds. The FVP weighs 59 pounds, so, but it still doesn't replace the thought. I don't know how strong most of you are out there, but I dare you to do this with your 2 lead acid batteries. It just boggles the mind to think that something that weighs 20 pounds has horsepower like the lead does. Seems like, you know, dollar for dollar, pound for pound, I didn't get as many poundage, but I think that's going to be all right. So we're going to run a test tomorrow. We're going to give you some more details on the lead acid and how it worked out and the average between the two tests. And then these bad boys are going in my boat, being tested if they survive the 7.5 hours. That's all I'm asking them to do. Because they need to be at least as good as my lead acid batteries as far as the length of time they're trolling throughout the day. If they go 8 or 9, that's not bad. But it's apples to apples. I know my trolling motor will shut off when things drop to 10.5 volts. I also know that I can run it at 4.5 or 4.5 on the prop speed, so it's apples to apples comparison in the tank. My wife also came up with the same thing I said earlier in the video. She goes, why are you charging and discharging those batteries a couple times without even putting them on the water? I said, well, I'm testing. I said, it's for my viewers. Now here's the interesting part. You take the cost of this battery and divide it by 2,000. These are supposed to do about 2,000 cycles or higher. So the minimum, 2,000 cycles, divided by what I paid for them, is 50 cents. The battery cost 50 cents per charge is what I'm consuming of this battery every time I charge it up for a whole day of fishing. You'll blow 50 cents guaranteed that day in a whole lot worse ways. Now those other batteries are good for 300 to 500 cycles if you treat them well. 300 cycles for the $208. I just did the math. 208 divided by 300 is 69 cents a piece per charge. $208 divided by, let's say I did 500, is 41 cents per charge. So 69 plus 41 divided by, or equals, divided by 2, we're going to have to take averages. 69 plus 41 divided by 2, 55. 55 cents for the lead acid battery. So if you want to do a dollar for dollar comparison, it's still 5 cents more expensive if we take the average of 400 cycles compared to the price of these. So just food for thought. This is 5 cents cheaper. It's hard to believe the $987 is 5 cents cheaper. These have an 11-year warranty. The other battery had a 1-year warranty. That's enough preaching for me for now. Let's go out there and see how them lead acid batteries did. Let's look at that data, and then we'll start compiling the data for the Dakota Lithium. Alrighty, we're back out here. We're about ready to do test number 2. I've got the trolling motor batteries. Come on, let go. All charged up. I'll show you the charge status on the charger here before we get going. We've got to disconnect or reconnect the breaker. That's important. As you can see by the charge status here, this yellow light normally is flashing when it's charging. It goes to solid when it's in full charge, which is awesome. We're going to unplug the charger. As you can see, the light went out. We're going to turn the breakers to the on position. We're going to turn the trolling motor on. Beep, 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 beep. Now that it's powered on, I'm hoping I got this thing adjusted about right for the barrel still. The motor's currently stowed. We're gonna go to Ultra, deploy. There we go. All right, deployed, 7 a.m. The voltage on the digital voltmeter is showing me 12.8 volts currently on the batteries. So we're gonna hit start. Water starts churning. We're at prop speed of 4.5. Now today we got a nice overcast day. I don't know how long it's supposed to be overcast, but when I did the first test, it was bright, sunshiny, hot. Very hot, in the upper 90s. battery's exposed to the sunlight, and it ran for 7.5 hours. 7 to 7.5. When I came out of here at the 7.5 hour mark, it had stopped. It could have stopped at 7:01, 7:02. But I'm calling it 7.5 hours. And that's continuous operation at 4.5 on the prop speed. So we just started this up. We're gonna let it ride. And we're gonna record the voltage and make sure it's still running every hour. Because I know it's hour 7. It should go to at least hour 7 hopefully this time. And we'll go from there. After this test is done, what you've seen I've done in the shop with the Dakota Lithium batteries, I'm going to swap those out, put them in here, and then once that's done, we'll test those. And we'll do it for 2 charge cycles as well and see if it performs as good as these FVP, cheapest lead acid batteries you can find basically. So far I'm not disappointed in the FVP, don't get me wrong. They're working well. Well enough that I got a guy that might buy them off of me when I'm done with them, because if I got the Dakota Lithiums doing what I'm doing, I don't need these, and I'll give him a good deal. They only have 2 cycles on them, and I'd pay $208. I'll sell them to him for $150 and give him the receipt. Fair enough? All right, because he does have, it's a buddy of mine, he does have a boat that needs 24 volts worth of batteries as well. All right, let's let this run. We'll see at the end of the test here. You don't have to stand here and listen to me for 7.5 hours, because that would absolutely bore the crap out of you. Alrighty, we concluded the second test this morning. And I say this morning because it started at 7 a.m. and it still ended before noon, which is not satisfying results. The first test, fully charged batteries, did 7.5 hours on the first go round of running at 4.5 on the prop speed. Well, I recharged them, fully recharged them with my normal charger. The light went from flashing yellow back to solid yellow, which means fully charged. It's the battery, it's the charger I've been using for a couple years now. Still works and performs as it should. Showed full charge, 7 a.m. My digital indicator. Now I have the digital indicator pulling information off of 1 battery out of the 2. And it was at 12.8 volts. At 8 a.m., so recorded this status every hour. It was 11.9 volts, 9, 11.6, 10, 11.2, 11, for some reason it said 5.6. And between 11 and noon, it shut down. So I'm gonna call this 4.5 hours, from 7 to 11:30, just like I did on the other one. I called it 7.5 hours. When I checked it at noon, for some reason, from 11 it said 5.6, then at noon the Minn Kota automatically powered off and it said 11.2. When she came back out at noon it said 11.2, which when it is low battery, there's just, when this thing shuts off, there is just enough battery to stow this thing away, and that's it. It moves really slow and sluggish too, but it gets it done. Usually I never run it down that low. I don't try to anyway. So we went from 7.5 to 4.5. We lost 3 hours of operational time after the first use. Second use, we were down 4.5. So that's pretty significant. Part of me wants to charge it up and run it down again, but you know, I don't want to sit there and run things unnecessarily. I'm thinking that's a good acid test right there. So what I'm going to do is I'm going to put the Dakota Lithiums in there that we've been looking at and playing around with. We're going to change those out, put the FVPs out on the ground, put the Dakotas in there, and we'll run the exact same test again to see how many hours we get out of the Dakota Lithiums. And then we'll charge those back up from shut-off, from Altera shut-off, to charge it back up to full charge, and then we'll run it one more time. And I'll charge it up the same way. They provided me with a 24 volt, 5 amp charger. This one here is a 24 volt, 50 watt charger. So I'm not sure how many amps that is. I have to look at, it doesn't say it on the front, so maybe when I pull it out of there I'll be able to see that. But we'll charge it back up to full with that and run a second test and see if the lithiums, brand new lithiums, hold up better than the brand new Deep Cycle super cheap batteries. I'm calling them super cheap because where else can you find a Deep Cycle battery for 104 bucks? But for 104 bucks, I can't say you got your money's worth, or did you get your money's worth? You decide. Let's get busy swapping out batteries. First thing you notice is you can grab both batteries at the same time and bring them out. That's awesome, because they're so light. Battery is in. Let's just see how it acts now. There you go, we're full power again. Yep, works as it should. That's good. Everything seems to be functioning. We're gonna power it off until we're ready to do the test. Alrighty, we're back out here early in the AM. As you can see, I got my boat covered because if I didn't, the dew would absolutely soak the boat. It's a lot of dewy mornings around here. So I'm gonna pull the cover back. I've got the Dakota Lithiums in there, as you saw, and we're going to go ahead and give this thing a full-on test today, running it at the 4.5 prop speed, 4.5, and dunk it into water, and we're going to check it hour over hour and see how it goes. As we saw, the FVP batteries went 7.5 hours first go round, 4.5 hours the second go round. After one cycle, I lost 40% of my capacity with those batteries, and that's when it went back to a full charge, which really, really disappointed me. So we're going to see how these Dakota Lithiums hold up, and those batteries are going back. They are junk. They will not. They're not going to do what I intended for them to do. If I lost 40%, even if it only landed there and I kept 4.5 hours every time, that's not enough for me. I know there's batteries with better capabilities, even lead acid with much better capabilities that won't degrade that much over time. My Napa batteries I had for 3 years did not perform that poorly. So we're going to get this cover off. We're going to get her up and going and start the timer, and we're going to check it every hour on the hour up till like 5 or 6 hours, and then I might look in on it every half hour. And I'll be checking the voltmeter, recording that as things, and I'll read that off to you. Now, another thing I want to note is I did charge these batteries up probably 4 days ago when I installed them, and they haven't been charged since. That would be, you know, let's say replicating a real life situation, in my opinion. We're getting ready to jump in here and turn the breakers on. We'll turn the power on, deploy, and go. Now I have this only deploying down this far so I can control the rotation going down in the barrel so it doesn't jam up on anything. Okay, timer set for 1 hour. 6:10 in the morning. Prop engaged. Thing moves quite a bit of water. As you can see here, possibly, maybe, right here, it says 4.5 or 4.5. And that's what we'll let her run at. We'll see how long she goes. Okay, first report out on the Dakota Lithiums is we fired them up fully charged at 6 a.m. Had 12.8 volts showing. Actually, it was probably about 40 minutes later when I finally looked at the voltage, it said 12.8. So this isn't a scientific, and this isn't a completely 100% lab tested results here, but we're at 6 a.m. we started up 12.8 volts. About 40 minutes later, at 7 a.m. it was still 12.8. 8 a.m. it was 12.7. 9 o'clock 12.7. 10 o'clock 12.5. So it's holding pretty steady on the voltage. At 12 it was 11.1, and in the middle of this test, I came out here and was just kind of wondering by. I'm like, the water's not churning. What's going on? Well, for whatever reason, it stopped. I'm not sure why. I powered the Minn Kota back on and hit the start again, and it took off just fine, and it ran for a few more hours. So I'm currently charging the batteries back up. Now, I will tell you that the free battery tester or battery charger, that was the 24 volt 5 amp charger that came with the batteries, is burnt up. I went to charge the batteries back up after this first test. I hooked them up to the 24 volt way and positive to positive, negative to negative, just like it's supposed to be, just like I'm running it. And I didn't see any lights come on, and I didn't hear anything. All of a sudden I heard a psst, and the smoke got out of the charger. So that charger is an absolute piece of junk, the one they send you. So right now I've got the other, they sent 2 chargers. They sent another 12 volt, 10 amp charger. So I'm having to charge the batteries up individually. That's no good for me, but I'm doing it for the test. I'm gonna get them both charged back up with the charger they provided, and we'll do a second test. I did get online and I ordered me a really nice battery charger. I know that Dakota Lithium sells one for about $275. That's fine. At this point, if they're willing to send you a free charger with their batteries that you just paid $987 for, and it smokes the first time you plug it in, I don't trust any other charger they would send me other than the one I currently have to charge up a lithium, because that's the only one I have. So I went online and bought me I got it in one in my other boat. Now I'm going to have one in this boat. A 3-bank battery charger. It's NoCo Genius. So we'll get more into that. So we're currently charging up the individual batteries. The other thing that I'm kind of worried about, and I'll say this right now, well, hopefully my suspicions will be false, is that with lithiums, you've seen them in your cordless equipment and whatnot, they're like, and they just like done. Well, when this one hit 10.5 volts and was done, I'm suspecting 10.5 volts and it was done, there was not any juice left to take it out of the water. It's just stuck. And that's not good either, because if that happens out to you out on the lake, you got to manually get this one up and out of the water. So this might be better suited, these batteries might be better suited for a manual deployed trolling motor, but more to come on that. And if that is the case, I haven't wasted my money, because I got 2 very nice batteries in my other boat that's manual deploy, and I got these lithiums here. I'll just swap them out. I'll put the lithiums in that boat and the lead acids back in this boat. But like I said, I haven't played around with it enough, so I'm not yet deciding that this is a good idea or a bad idea. Just because of the nature of lithiums, and that they don't have that, what do you want to call it? They drain all their energy completely, pretty much. Where my lead acids, you know, even though it went low on voltage and it shut off, it had enough juice to stow the trolling motor away. Anyway, we'll get these charged back up, get you some more information, and then at the end of the video, I will have I don't know, it might be a fairly long summation, maybe a little whiteboard work as to what I'm discovering with these batteries versus the old FVP batteries that I had. And like I said, I've had good luck. I had Acid Deep Cycle. They worked well in the past. They lasted about 3 years. Probably would have lasted me 4 or 5 even, depending on how many cycles I ran it through, but having a even better charger on board, like I do on the old banana boat back there. Anyway, it's been fun trying to discover these results, find out what does work. I did take the FVP batteries back to the big box store yesterday, and the lady there, it was funny, she goes, "Would you like to exchange for some more batteries?" I'm like, "Nope." I said, "Lesson learned. I just want my money back, and thank you. Have a nice day." And they took it back without even any questions, so that was awesome. All right, I'm gonna have to switch this over to charge the second battery, and then once the second battery is fully charged, we'll do the test one more time. We're back out here with the batteries fully charged. I just checked the voltage. It's at 13.5 right now. We powered on the breakers. Okay, everything seems to be working. Seems to be running pretty fine. Take her down to 4.5. Stop her. Dunk her back in the water. Power it on. Go a little deeper. All right, power on. Top speed 4.5 at 6:04. We'll just call her 6 o'clock in the PM. All right, now that we got that running, no matter where I end up with these batteries, whether in my other boat or this boat, I'm gonna end up wanting a smaller battery box to contain these. since these are quite a bit smaller than the 27 series lead acid battery, deep cycle lead acid battery. So I'm gonna get in here and take a measurement on what size my box needs to be, and we'll go make a box real quick, and I'll bring you along for that little bit while this is going. This is gonna be a few hours. All right, let's take a measurement this way. We gotta make sure we don't touch the post together, eh? It's like these are about 9-inch. Would get it. We're gonna make them 9 by 11. It's like 9 or 10 3/4 would be good, but I want a little bit of wiggle room. 9 by 11 it is. Well, I just so happen to have some leftover starboard from when I installed the floor on my boat, you know, 4 years ago. So we're just gonna, we got a straight edge here, that's pretty straight. So we're gonna just mark us off at 11 here. 11 and 9. Now, how do I want to do this? Yeah, I'm gonna make this by 9 by 11, and then I'm gonna put I'm gonna screw the sides into the side this time. I'll do it that way. Let's put the old Mac Daddy homemade rip fence on here. Now we're going to go our 11-inch route. Now we'll rip some sidewall pieces that I'm going to screw onto here to trap the batteries into location. All right, there she is, the battery box all built. We're gonna take my little deburring knife and just kind of soften these edges. If you haven't worked with starboard before, it's kind of neat. It works like a wood that doesn't splinter. And I'm using just, you know, regular drill bits on this, along with regular wood screws to put it all together. Is it perfect? Heck no. Is it good enough? You bet. It'll outlast the batteries, I'll guarantee you that. Like I said, I'm just taking off any sharp edges here. As you can see, this stuff just, you can put a nice radius on it in no time. Share your thoughts in the comments, what you think about. Now, I know they make battery boxes for batteries. They don't make battery boxes for these lithiums. So, and I like to have them exposed with as much air around them as possible so they cool off. This isn't going to be much. This is going to have some airspace in here. It's actually, with this foam, vented underneath it with the ribs. If you really need that. Cool. We'll see this later on in the video once I install it in the boat under my batteries, once the test is complete. All right, folks, we've got some conclusion here. You might hear a little buzzing in the background. Somebody else doing a little work over to my right. That's fine. He can keep on working. We'll keep on talking. So, full charge. I'm not completely and 1000% impressed with the lithiums. Because, well, 1, 2, 3, 1, 2, 3, 4, 5 hours to dead, from fully charged to dead. Part of me wonders if it has to do with the battery charger they provided me, because you know the first one, the 5 amp 24 volt, the smoke got out as soon as I plugged it in. This one here is a 10 amp 12 volt charger. I plugged it in and you can hear a little fan going and the light's red and the light turns green when it's done charging and all that fun stuff. So I do have a better battery charger, and I do have, let's just say a much better battery charger than I'm going to put on here that I bought, but that's going to be another video. So in conclusion, FVP batteries are no good. They went from 7.5 hours, which outperformed these, to 4.5 hours, which doesn't outperform these. So these are supposed to be good for 2,000, 3,000 cycles, 200 to 300 for a lead acid deep cycle. These are still worth the money. I really question the 4.5 hours, 5 hours, the 5 hours I got out of this before it went dead. Now, here's my biggest worry. This is dead right now. And with it being dead, I can't stow it. The battery just went down to zero. If you ever worked with lithiums or DEWALT batteries, when you're using the drill and they go, and they fall off hard and they're done. Well, that's what these do too. These are lithium. They went off, they fall off extremely hard. And then you've got nothing to stow your trolling motor away with. It's done. So part of me wants to say, for this style of self-deploying, self-stowing trolling motor, lithiums might not be the answer. I'm actually going to conclusively say this, unless somebody tells me otherwise. You guys feel free to leave comments down below, because I do have another set of lead acids in deep cycles in my banana that I could put over here, and that might be what happens. And the banana gets the lithiums because the banana has a manual deploy and stow, so I would never be in that situation. If the trolling motor goes dead, I can still stow it away, no problem. Plus the banana can benefit more of a 78-pound weight savings on that boat. This boat doesn't care about how much weight I get in it. It just still gets up and goes, hits top speed no matter how many people I got in it, to a limit. What to do? I think we're gonna have to drag the other boat out here and do some battery swapping. In conclusion, lithium, no, for the stow and go. Lithium might be pretty good in a manual deploy and manual stow situation. That's what I'm going to go with. And the chances of me taking the banana out fishing more and more often than this boat is pretty high. This is a great one for going out in the river. The banana is good for going out in smaller lakes, smaller rivers and whatnot like that. So I think that's what we're going to do. Hope you folks learned something today. I hope you found this video informative and helpful. And this is Michael saying, if it ain't broke, fix it till it is. And we'll see you on the next video.